All right, today we're going to look at the Law of Cosines, the second half of 4.7. So we have 6 formulas here, but really it's not 6 formulas that you have to memorize. It's more memorizing a pattern. So we have 3 formulas for looking for a side. And we notice with each one of them, we have a squared, b squared, and c squared. Now, if I have a squared, then I'm going to be taking the other 2 sides, b and c. I'm going to be squaring them. Then I'm going to subtract 2 times those same 2 sides, b and c, times the cosine of angle A. And notice, angle A is the same side that we're looking for. So if we're looking for A, then we're going to use cosine of angle A. Now we're going to have that same type of pattern in the other 2. So we're looking for b, so we're going to have b squared, and notice we are using cosine of b. Then everything else is the other 2 sides. So a squared plus c squared, and then minus 2 times a times c, and then times that angle. The same thing goes if you're looking for side c. Now, what about angles? So for angles, if we are looking for cosine A, or if we're looking for A, B, or C, you notice that this is really just a modification of this. So basically, they have taken the formula that's on the left and they've solved it for cosine A and come up with this formula right here. So if we are looking for angle A, then we're going to do cosine A equals, and then we're going to do the other 2 sides squared and added together, minus the side of the angle that we're looking for, divided by 2 times the same 2 sides that we added together. So if you kind of just memorize those patterns, then it's not 6 formulas that you have to memorize. It's really just getting the pattern down. So we're going to take it and we are going to apply this. Oh, and one other thing. If we are looking for an angle, this formula is going to give me cosine of that angle. So let's say it comes out to cosine A equals 0.5. Then you're going to have to put in your calculator, you're going to do inverse cosine of 0.5. So you're going to hit second cosine, which in the calculator will come up as that. And then in the calculator, you're going to put 0.5, and then it's going to spit out the angle for you. So if you are looking for a side, then you're just going to plug it into the formula, take the square root, and you have to take the square root because this is squared. If you're looking for an angle, you're going to plug everything into the formula, and then you're going to do inverse cosine of that answer from the fraction, and that'll give you your angle. Okay, so let's take a look. So solve triangle ABC, as we discussed the day before. Solving a triangle means to find everything that we don't already know. So if we look at this triangle that we have, we do not know angle A, so we're looking for that. We do not know angle B, we're looking for that. We do know angle C. Then our sides, we know side A, so this is A. We know side B, this is B, and we do not know C. So those are the 3 things that we need to find to solve our triangle. So with law of cosines, if we go back up here and look at the formulas, if I want to try to find an angle, so notice for any one of these formulas for finding an angle, I have to know all 3 sides. I have to know side B, side C, and side A. So in any of them, I have to know all 3 sides, which tells me that before I can try to find any angles, I need to know all of my sides. So we're going to start there. We're going to find the one side that we don't know. So we don't know C. Therefore, we're going to use our little formula to find side C. So we want to use the C squared formula. So we're going to have C squared equals, and then we're going to take the other 2 squared, so A and B squared. So A is 5, so we have 5 squared, plus B, which is 8, so 8 squared. And then we're going to subtract 2 times those same 2 sides, 5 times 8, times cosine of, remember, the angle of the same angle of the side we're looking for. So we're looking for side C, so it's going to be cosine of angle C, which is 65. So then we're going to plug all of that into our calculator. 5 squared plus 8 squared minus 2 times 5 times 8 times cosine 65. I'm literally going to type it in the calculator the way it is. And I'm going to get that C squared comes out to be 55.1905-ish. Now remember, this is C squared though. So in order to get C, I need to take the square root of that answer. So to use the exact calculator from your, or exact answer from your calculator, you're going to say the square root, and then you're going to do second negative, and it's going to give you this whole number, but the square root of it. So then, if you plug that in, C comes out to be approximately 7.4. So just like in the problems from the first half of 4.7, we're rounding side lengths to the nearest tenth, which is why I rounded it to 7.4, and then angles to the nearest degree. So we know side C is 7.4. Now that we know all three sides, we are able to look for missing angles. So let's go ahead and just start with A. So if I want to find angle A, then I'm going to do cosine of angle A equals, and then remember, we're going to take on the top of the fraction the other two sides, B and C, squared and added together. So B is 8 squared plus C is 7.4, and we have to square it. And then we're going to have minus A squared. So it's going to be minus A because we're looking for cosine A. So minus A squared, and A is 5. All right, then in the denominator, we're going to have 2 times those same two numbers that we used first, 8 and 7.4. So times 8 times 7.4. So if you put that fraction in the calculator, so just that fraction, then we're going to come up with 0.792. And you might be better off, some of you, it will help if you go ahead and just type the numerator in and get a number, type the denominator in, get a number, and then divide those two numbers. That's going to give you your 0.792. All right, once we have that, then we're going to use the calculator to actually find the angle. So angle A, you're going to hit second cosine, and then second answer, and you're going to come up with that your angle is approximately 38. So angle A is 38 degrees. Now that we have two angles, because they gave us angle C, and we just found angle A, then we have one more angle to find, and since we know all angles in any triangle add up to 180, we can simply add the two that we know. So we know angle C is 65. We know that angle A is 38. So we're going to add those together, and that gives us 103. Then we're going to take 180 and subtract that answer. And we're going to come up with 77. So angle B is 77 degrees. So we now have this triangle solved. There's everything that I didn't already know. All right, let's take a look at another one. So we're still solving triangle ABC, rounding side lengths to the nearest tenth, angles to the nearest degree, but this time they have given us all sides and no angles. But that's okay. Law of cosines, I have to have all the sides to find angles anyway. So law of cosines is set up perfectly for this. So then, since I don't know any of the angles, let's just start with angle A. So then, if I want to find angle A, then I'm going to do cosine A. Actually, let me make my list first of what I don't know. So I don't know angle A, angle B, or angle C. These are the three things I need to find, and I'm not done until I have answers for all of those. Alrighty, so to find angle A, we're going to do cosine of angle A equals, and then think back to the formulas. I have to use B squared plus C squared minus A squared on top. So b squared plus c squared minus a squared on top. Remember, it's minus a squared because we're looking for a. Then on the bottom, I'm going to have 2 times b times c. So because this is b and this is c, then these need to be b and c. So b is 50, c is 64, and therefore I'm ready to go ahead and put that in the calculator. So if I type each number, or type the top of the fraction in, type the bottom of the fraction in, this is going to come out to be 5075 if you type that in. And then the denominator, if you type that in, comes out to be 6,400. So then we go ahead and divide that and get a decimal for that fraction, and we find that cosine A equals 0.793. Now to find the angle, so angle A, you're going to type inverse cosine, and then you're going to put this in, or you can do second cosine, second negative, and it'll use your exact answer. And you're going to come up with the angle is approximately 38 degrees. So angle A is 38 degrees. Now at this point I have 2 choices. I could switch back to law of sines, because a lot of us like law of sines better, because I do now know a side and an angle with the same letter. However, I really try to avoid using answers that I have found, if at all possible, because what if I messed up this 38 degrees? If I use it in another answer, then that answer is going to be wrong because I used a wrong answer to find it. So although I can switch over to law of sines at this time, I'm going to stick with law of cosines and find another angle. So I'm going to go ahead and do angle B. So cosine of B equals, and then I'm going to use my sides again. So since I'm finding B, then I need to do a squared plus b squared, or sorry, a squared plus c squared, and I have to subtract b squared because I'm looking for b. So a is 39 squared, then plus c squared, which is 64 squared, minus b squared, which is 50 squared. Then on the bottom is going to be 2 times 39 times 64. All right, so I'm going to type that into my calculator. And you can do it all at once, or you can do it numerator, then do the denominator, then divide the 2. Either way, you should get 0.624-ish when you're done. Now to find the angle, so the angle B, you're going to do second cosine, and then you're going to use that last answer you got, that 0.624, and then you're going to come up with your angle is approximately 51. So angle B is 51 degrees. Now since I know 2 of my angles, I can easily find the third by just adding them together and subtracting from 180. So 38 plus 51 gives me 89, and then 180 minus 89 gives me 91. So I know that angle C has to be 91 degrees. So that's law of cosines. Again, if you memorize the pattern more so than the formula, then it's really not that hard. So you want to look at these and really kind of come up with the pattern of, okay, I'm looking for this, so this is what I use. Now we have one other problem that we need to do for today, and that is Heron's formula. It is another formula that we can use to find the area of any triangle. So we learned one formula yesterday, and this formula is going to be used if all you know is the sides. So I don't know any angles, but I do have to know all of the sides. So this formula, there are actually 2 formulas that we need to know, and the reason is the area formula is the square root of s times s minus a times s minus b times s minus c. And a, b, and c are our side lengths. Now, the question is, what is this s that they're using in the formula? Well, that's going to come from this. So you actually have to do this first, to figure out what your S value is. And then you're going to take that and you're going to plug it in here and do that second. So S is simply going to be the 3 sides added together and divided by 2. Not 3. It is a temptation to divide by 3 because we think we have 3 sides, let's divide by 3. But it's not an average. It's the 3 sides added together and divided by 2. Then you're going to take whatever that value comes out to be and you're going to plug it into the area formula. So it seems a lot worse than it is. So let's go ahead and take a look at this example. So we want to find the area of a triangle whose side lengths are 38, 45, and 51. So that's our A, B, and C. So first thing we need to do is find our S value. So we're going to take those 3 sides and we're going to add them together. And then that's going to need to be divided by 2. So when I add those all together, that gives me 134. Then I divide by 2, which gives me 67. So my S value is 67. Now I want to plug it into my area formula. So everywhere I see an S, that's going to become 67. And then my A, B, and C are my 3 side lengths. And it doesn't really matter which one is which. I tend to go A, B, and C and put them in order, but technically it doesn't matter. So let's go ahead and fill into that formula and we can be done. So area is going to equal big long square root. And the first thing we have in here is just S. Well, we found that S was 67. Then we're going to open our first parentheses. And in that first parentheses, we have S minus A. Well, S is 67 minus A, I chose to make 38. Then we're going to open our second parentheses, and we have S minus B. So S is 67 minus B, which is 45. Then we open our third parentheses, and in that third parentheses, we have S minus C, which is 67 minus C, which is 51. Okay, so all of that is inside the square root. Now, you can go ahead and simplify each one of these parentheses, but if you're using those blue calculators that we have in class, you can actually type it in just the way it is. I'm going to go ahead and simplify just so it looks a little bit nicer. So the 67 is going to stay 67. Then in that first parentheses, 67 minus 38 is 29. And then in the second parentheses, 67 minus 45 is going to be 22. And then in the third parentheses, we have 67 minus 51 is going to be 16. Now we can multiply that all together and then take the square root of it. So then the area, once we do that, will come out to be 827, and then it rounds to 827.0. Now we do have to put a unit on here. Since our side lengths are given to us in terms of feet, our area must be in terms of feet squared. And so then that's our answer. So much easier than it looks. You just have 2 little formulas you have to use. Make sure that you find your S first, and then take that S and plug it into the area formula. All right, so that is it for the second half of 4.7, Law of Cosines. Much shorter than the day before. So hopefully that all makes sense, and I will see you next time.